Hello, Python programmers. Let's talk about functions. When we write code of any size, beyond just little tiny academic exercises, it's very important to strive for modularity. Modularity greatly enhances the ability to read the code and the ability to maintain the code. And those two things are significantly important because code is written once and read many times. It's read by people all around the world working in groups, different backgrounds, different perspectives, different expectations, different experience levels. And we can greatly simplify these jobs by writing smaller pieces of code and putting them together to work as a team to make up one big application. We could conceivably write our entire program in one Anaconda Jupyter Labs cell, but that would be silly. So we break it up. We define the concept of a function as a named block of code, and that named block of code only runs when it is called. We also use the term invoke. We may call a function or invoke a function. We have ignored object-oriented programming for the most part in this class. Classes, or objects, if we think about object-oriented programming, have functions, but they're called methods. Same philosophy, same technology, but the function belongs to a class, which is instantiated into one or more objects. So when we say function, you can also substitute the term method, and the mechanisms are still the same. On this slide, then, we've demonstrated the world's simplest function, say hello. It just simply prints out a message to the console. If I take that back over to Jupyter Lab, I have a bright, shiny new notebook I created. This is a function. It consists of one line of code. The function has two structural requirements. It needs a definition definition line, which is indicated with a DEF keyword for define. And it has one or more indented lines of code, which the indenting delimits the lines of code that are in that function. If I put another line right here, this line of code I have just added to the cell is not in the function because it's not indented. This is syntactically correct, it's just a little awkward. We can certainly do that. I'm going to take that out. This function does not yet exist in our environment. We have a thing called a kernel, which is the Python working environment where our variables accumulate and our function definitions accumulate. But this little guy is not in the kernel, or I refer to it as the environment yet, because I have not executed this cell. And you can tell I have not executed this cell because the index number next to the cell to the left is not populated. So when I hit that run button, I can run the individual cell that defines the function in the kernel, and now I can invoke it. And in the following cell, I'll just reference the function by name. And then when I execute this cell, it calls the function. The output appears below the cell that I just executed, but that output was actually generated by the function. Now if I make a change to the function, that change does not become part of the function definition until I run that cell again. If I run the second cell that invokes my function as I did a moment ago, I get output from the original definition of the function, not the new definition. So I need to run this definition again. And you can see the order of things that have taken place now. The say hello cell ran third, and then after that, the definition of the function ran. So the index numbers will tell you the order of things that have executed in the cells. Now that's fairly helpful when you have a very small number of cells, but that gets quickly out of hand if you're writing a program of any complexity. I still encourage you to think top down, because if you try to keep track of what has run and what has not in any other sequence beside top down, it will cause confusion. If I run it again, keeping in mind I have already redefined the function, I'll run the function call again, and there I get the new definition of that function. If the function, let's throw another function in here. Let's say def not sure yet. I know I need to write a function. I have my intuition telling me I need to modularize. Eventually some code will go in there. The keyword pass says that not ready to put anything in there yet, but here's a placeholder just in case. And I can run that, and now I have a definition for this function, and I can begin to use it, but it doesn't yet do anything. In software engineering parlance, we would call that a stub. In Python, the pass keyword lets us define that stub. Of course, if I call that down here, I won't get any output. Returning back to our slides again, slide 4 is just a reiteration of what I already illustrated for you in JupyterLab. We defined our function, and if you look at the postmortem in the slide in the screen snip, the index numbers for the cells tell you that I ran cell 2, then I ran cell 3, and since I ran them in that order, cell 3 functioned correctly because it knew about the definition of that function. And again, just to beat that dead horse a little bit more, be very careful running things out of order. And if you're totally lost and you need to start your environment from scratch, click that double arrow, and that will run the cells sequentially from top to bottom, reinitializing all the variables as necessary and cleaning out any existing variables that you have. And I find myself doing that periodically when I'm processing a lot of data, step by step by step. Sometimes I just get out of order and I've got some intermediate values I'm not quite sure about, therefore I just start over and run everything from top to bottom. On this slide 6, we illustrate the fact that if you haven't defined the function yet, you will get an error when you try to invoke it. And in this example, I intentionally reversed the order of the function call with the function definition. The call preceded the definition. You can see from the index numbers to the left of the cells that I have not even executed the cell that defines the function. The index number is blank there. So when I try to call it in the second cell, it fails. And it's the error messages say hello is not defined, which causes some consternation because you can see it right there. The point is, it hasn't executed yet. That cell has not been run or executed, and therefore that definition of that function does not exist in the kernel yet. In this slide, again looking at the cell index numbers, you can see that I ran the definition and then the index number of the cell preceding the definition is higher, it's a 4. That means I ran the invocation or the call of the function after I ran the definition because 4 follows 3, even though physically that 4 precedes the 3. So that's a logical ordering of the execution of the cells, and it's independent of the physical ordering of the cells in the notebook. Once we figured out how to call functions and define them, we can pass them arguments, which is very powerful. In this example, we've modified our sayHello function to accept a parameter. And I will flip back to Jupyter Lab and I will just modify my function. And I added to the parentheses following the function name in that definition some variable name that I just made up off the top of my head. There's nothing special about that name. And that is a piece of information that you have to provide now when you invoke that function. That is required. And let's rerun that cell to redefine that function in the kernel. And then when we try to invoke it now with no arguments, it will fail. And the error message is good. Say hello, missing one retired, missing one required positional argument name. That's pretty good. It tells you what you did wrong. The invocation does not match the definition of the function. Now, since this is Python, I can put anything I want, any single value in those parentheses. I can put a list, a dictionary, a floating point, a string, a Boolean, because there is no validation between the argument I provide and the parameter where that argument lands. Most other languages make some attempt to verify that you are using the expected data type when you pass an argument to a function. The data type used as the argument must match the data type specified in the parameter, but we don't do that in Python. We take what we get and we run with it. Now we're good. In the cell where I'm invoking the function, I'm passing 123 as my argument, and that should run. There you go. I don't get an error message anymore because the function expects one argument to be passed, and I'm passing one argument. Well, this function, while it is happily accepting an argument into that parameter name, is doing nothing with that argument. So it would be nice to do something with that value. And let's just at the very least print it out. You passed me, and then we will print, and I'm doing this on separate lines for a reason. Now at least we'll print out whatever was passed in and whatever lands in that parameter. Again, redefine the function, click the run button on that cell, reinvoke the function, and it says you passed me 123. That's all well and good. Let's do it again. Let's call sayHello again, and let's pass it a string. Remember, since Python doesn't care. It would be up to us to validate at some level the data types. But we're not doing that. We're still good. We're skating by. It prints out 1, 2, 3 the first time we call it. It prints out Bill the second time we call it. That's fine. But let's make it a little more picky. Let's define the function this way. How about this? You passed me, and then I'm going to put a plus sign followed by name, and I will remove this second print. Now we're attempting to concatenate using a plus sign the string enclosed in quotes, you passed me, and whatever is in that parameter. Now this is going to fail because 123 is not a string and this concatenation operation cannot take place. Watch this fail when let's first redefine the function, don't forget. Try to invoke it. There we go. I got an error, can only concatenate string, not integer, to another string. And that error took place in the function. The point here is that data types matter, even though it seems like they don't, because this function now is assuming that whatever I'm passing to it can be concatenated to a string. And you cannot concatenate an integer to a string. And I'm introducing this because your takeaway should be that data types matter, even though it seems like they don't. A workaround for this would be to check the data type of name before we attempt to do this concatenation. We could add some code to this method to make it a little bit more robust and refuse to do that concatenation if it's not possible. That's beyond our scope right now, but just rest assured that it is possible to handle these situations a little bit more elegantly than letting the program crash. We saw this. Well, that brings us to the end of our presentation. Let's go back to Jupyter Lab and touch on one more topic. I am going to create a new notebook just to have a clean workspace, and we will do returning values from functions. I'm not spelling right. Returning values from functions, because sometimes it's useful, very often it's useful, to have the function compute something and then send it back to whoever called it. And let's make a function. We'll call it init data. Keep in mind that my naming conventions are a product of my years and years of experience with other languages. I think a true Python aficionado would use snake case, lowercase letters in the name, words separated by underscores, but I am not in that habit. It works the same either way, it's just a style issue. Let's say then, for the sake of argument, that this function initializes a, let's say, random list of numbers and returns it. And then I can make use of this function to do other nifty things. Remember from your reading that a list is a formal Python data structure. We're not just generally talking about the nebulous concept of a list. So how am I going to create a random list of numbers? Let's just say, for the sake of argument, that I don't know. And let's use our search engine to figure it out. I'm using DuckDuckGo because it doesn't spy on me. And I will say Python random list of DuckDuckGo has seen this all before. Many people are doing these searches. It offers me three choices that look very interesting: random list of integers, random list of numbers, random list of integers in range. And there's another one, random list of int. I'm going to take the first one. One of the things that we develop over time is a feel for what sources are good, somewhat authoritative, what sources are annoying, or maybe are fraught with typos. We see there our first response, our first result in the search is moonbooks.org. I have never heard of moonbooks.org. If you think that's something that you want to investigate, feel free. But I will tell you from my experience that I have good luck with Stack Overflow. If I scroll down, there's another Stack Overflow result. You can see a pattern developing. Geeks for Geeks has appeared twice. Tutorials Point, you'll see that quite often. But over time, you'll get a feel for what speaks to you and where you can find good solutions. And employers want you to be able to do this. They want you to be able to build a search phrase to solve a problem. You can certainly grab your book and read through the book, and eventually you will find a way to do what we want to do, to create a random list of integers, but it would take you much longer to thumb through the book or to page through an ebook than it would just to search for it. Well, I never went and looked. Okay, let's take the first Stack Overflow. This says I'd like to create a random list of integers for testing purposes. That kind of sounds like us. We just need a random list. And if I have a feel for the question being what I'm interested in, I just scroll down. This looks rather complicated. Oh my gosh, I've got two import statements, which I don't have at this point. I've got something called a timer. Right away, I've lost interest because it just looks way too complicated. Here's another one. Int 1000 times random.random for I in X range. That looks reasonably interesting. Not too complicated. Is there another one? Here's one that uses list comprehension with a for loop. Here's one that does something with range, but I don't see any mention of random there. So I'm not getting a great feeling about this. And if I scroll back up, I notice that this original post had some concern about time and time consuming, and I really don't care about that. All right, just for the sake of curiosity, let's go to the second Stack Overflow result. I skipped over Geeks for Geeks. I skipped over Moon Books. Let's take a look at that one. And this person is getting an error trying to run a program. And this person has a loop. They're doing a for loop with a range from 0 to 7 inclusive, and they're generating random numbers on a list. We could try to make that work. Let's take a shot. I need this much code. I don't need their function. I already have a function. I'll skip the def statement. But I need the rest of that code. I'll just take it back over to, whoops, my Jupyter lab, and I'll just paste it in. I see a problem right away. The indenting is different. My indenting looks to be one tab or 4 spaces. And I'm going to need to clean this up because if I don't indent consistently, I will get an error when I execute this function definition. All right, I think I have it indented correctly now. Let's take a look at it. This person created a list using the empty square brackets notation. That anytime you see square brackets, it's either a list or an index function. Index operation, sorry. Then we create a variable and initialize it to 0. I'm not sure why he did that because he's using it as his loop counter, so it automatically gets incremented to 0. And then he just simply loops 7 times and adds a random number between 0 and 10 to his list. Finally, here's what we're really interested in. He returns the list using a return statement. And this is not indented right, is it? That needs to go there. Okay, let's try to define that function. Well, Python was happy with the function definition, meaning it's syntactically correct. It might not be logically correct, but we'll see. Then down below, let's try to use our function. And I will say answer equals init data. And this invokes the function. And store the returned value in answer. Answer is a name that we just made up. It's a variable that will poof into existence as necessary. We don't have to declare it because this is Python. And then let's just print it out. Okay, ready? We've already executed the function definition. Let's execute the function call. I get an error. Random is not defined. Okay, no problem. If you want to go through the research, if you Google that error message, or if you DuckDuckGo that error message, you will find out that you need an import statement. Now, can I put it right here? Let's try that. Still didn't work, but we got a different error now, so we got random working. This says list assignment index is out of range. Okay. So somewhere in here we have a problem. And it's blowing up on the statement where we're attempting to use the index. If we do a little more research, which means going back and reading the documentation that we didn't really study in the first place, we find out that the code that we copied had a bug in it. And that's why it's not working. And just to skip to the chase here, what we need to do is instead of doing the index operation, we do an append which will add a new number to the list. We can't dynamically increase the size of a list simply by using the index operator. We have to use the append function. So let's see if that fixed our problem. Let's redefine the function. Okay, didn't get any errors when we redefined the function. That's good. Now let's rerun the call to the function. And there we go. So we fixed the bug in that code that we were trying to use off of Stack Overflow. And the reason we were able to fix it was because we found a comment, or actually several comments. You can't assign a list dynamically. On the contrary, append is needed. So we were able to make the fixes based on commentary about that code. And had we scrolled down, we would have found that solution as well. And this is one of the ways that we solve problems, by researching them online and adapting code snippets to our solution. Perfectly acceptable. Getting back to our point of emphasis then, this return statement will give you whatever was computed in the function, and you have access to it by assigning it to a value when you call that function. Or you could just print it out too. If you want to do a print init data open close paren. So this calls the function and print whatever it returns. We're calling the function 2 times. In the first case, we are storing what it returns to us. In the second case, we are not storing what it returns to us. We're simply printing it out immediately. Let's make one adjustment to this. Notice that in this cell that we are repeatedly executing, we are importing random, the random library, over and over and over. Every time we run that cell, we're going through the operation of opening that file on the disk, bringing it into our working environment, and that's redundant. We only need to import it once. What I recommend is that at the top of your program, top of your notebook, create a cell that does nothing but import your necessary libraries. We don't need any other libraries in this example, but in the future we'll be importing a lot of things. And that lets you consolidate all your import statements. You can easily look at that and see how many things you're importing rather than scattering them throughout the cells. It also allows you to run this once and not have to run it anymore. Makes your programming more efficient. Once a library gets imported, it stays imported until you restart the kernel. Therefore, I can click execute on this cell, and it's going to stay that way. I don't need it anywhere else now. I don't need it down here when I call the function. I don't need it in here when I'm trying to do operations with a random class. Again, group those together near the top or at the top. And I think that makes your programming more efficient and more easier understood, more easily understood, because all those import statements are grouped together. If you need some more information, if you'd like another perspective, here is a very nice function overview from W3 Schools. W3 Schools is an excellent resource. I consider it to be close to authoritative. It is short and sweet. There's not a lot of detail here. It doesn't go into every arcane thing you can do with a function. It doesn't reflect every little detail mentioned in the Python language spec, but it's enough to get you started and to fill in some gaps. W3 Schools highly recommended. Thank you.